We are on the back of the first page, so we're going to take a look at the next three. At the top of that back page, you have 30 newtons going to the right, 30 newtons going to the left. So we have a 10 kilogram object. Let's go ahead and take a look at the other forces. We have mg going down, and we have a normal force going upward. So we know that this is potentially only moving in the x direction, so the sum of my forces in the y direction is going to equal 0. And my normal force, sum of my forces in the y direction, is going to equal normal minus mg. So they're going to be equal to each other. So my normal force is equal to mg, which is 10 kilograms times 10 meters per second squared. So my normal force is equal to 100 newtons. Now I don't see a mu anywhere, so there's no friction that's involved. And I'm going to now look at my x direction. So I have 30 newtons to the right, 30 newtons to the left. So the sum of my forces in the x direction is going to be 30 newtons minus 30 newtons. So you guessed it, we have 0. So 0 net force. And then if my net force is equal to 0, remember force over mass equals acceleration. Well, if this puppy is 0, then that means my acceleration is also going to be 0. All right, let's take a look at this next one. Here we have an object that is being pulled upward with a 30 Newton force. My assumption will be that there's potential for it to be in equilibrium in the y direction, but let's just look to make sure. In order for it to be in equilibrium, remember that your normal force goes up to the weight of your object. So I have mg down here. I have a 40 kilogram object, so that equals 400 newtons. I have 30 newtons here, which means that I do indeed also have a normal force happening here. Sum of the forces in the y direction is going to be 0 because that force pulling is not enough to overcome the weight of the object. So therefore, there is still a normal force. Sum of the forces in the y is equal to 0, which is equal to normal force plus 30 newtons minus the 400 newtons, which is my mg. So if I look at what the normal force is, it's going to be 400 newtons minus 30 newtons. And so my normal force will be 370 newtons. As far as the x direction, I don't see any force over here. I don't see any force over here, and it doesn't talk about friction at all. So the net forces that are here in my x direction are going to be 0. And if there's no forces in that x direction, I'm not going to have any acceleration either. All right, let's take a look at this third one. In this one, again, I don't have a mu here, so I'm assuming there's no friction. Let's draw our forces. We have mg going down this way, which that's going to be 10 kilograms times 10 meters per second squared, which is 100 newtons. So that means if this is in equilibrium, right, sum of my forces in the y is going to equal 0, then this is also 100 newtons, which is my normal force. So I'm going to put that down here. The sum of the forces in the x direction, super easy. I've got 40 newtons and 15 newtons. So sum of the forces in the x is going to be 40 newtons minus 15 newtons, which is going to equal 25 newtons. And then my acceleration, remember, is my net force, which is the sum of the forces in the x direction in this case, over my mass. And my mass is 10 kilograms. I'll just write mass here. 10 kilograms with 25 newtons up above. That's going to give me 2.5 meters per second squared as my acceleration.